Welcome to Think Global Education Services. In this video, we will learn about back titration. As the name implies, a back titration is done in reverse by returning to the endpoint after it is passed. It is used when the endpoint is hard to identify or when one of the reactants are impure. In this method, a known excess of one of the reagent is added to the reaction mixture and unreacted excess reagent is then determined by titrating against a standard solution. So by this means we can determine the strength of unknown solution by using a standard solution. So we will learn how to determine the strength of unknown solution by solving the below given problem. In this reaction, we are adding an antacid tablet which contains sodium bicarbonate. To this reaction chamber, hydrochloric acid is added, and once when the reaction between the sodium bicarbonate and the hydrochloric acid is completed, the excess amount of hydrochloric acid which is remained unreacted will be determined by means of titrating reaction mixture against sodium hydroxide. So we have to first consider the original reaction, which is between the sodium bicarbonate and the HCl, in which the solid sodium bicarbonate reacts with aqueous HCl to produce aqueous salt of sodium chloride with the liberation of carbon dioxide gas. So the mole ratio in this reaction will be 1:1. So now we have to calculate number of moles of HCl added to the reaction chamber. So number of moles of HCl totally added can be obtained by multiplying the volume and its concentration, which is given, which will be equal to 0.00313 moles. So now we shall look into the titration reaction, which is between the HCl and the NaCl. The excess of unreacted HCl is titrated against the aqueous NaOH to produce NaCl and H2O. So the mole ratio of the titration reaction will be 1:1. So number of moles of NaOH can be calculated as, which will be equal to 0.00350. It's constant. It's 0. The volume of the NaOH used multiplied by its concentration, which will be equal to 0.00070 moles. Since the mole ratio of NaOH and the HCl is 1:1, we can equate the number of moles of NaOH, which will be equal to number of moles of HCl unreacted, which will be equal to 0.00070 moles of HCl unreacted. Therefore, we can determine the number of moles of HCl reacted for the neutralization reaction by subtracting the total number of moles of HCl total and the number of moles of HCl unreacted, which will be equal to 0.00313 minus 0.00070, which will be equal to 0.00243 moles. So from the mole ratio in the first equation, the number of moles of NaHCl will be equal to number of moles of HCl as they are reacting in the 1:1 mole ratio. So now we can determine the mass of the sodium bicarbonate which is being obtained in the reaction to calculate its mass by percentage. Therefore, we know that mass is equal to number of moles into molecular mass. So we know the number of moles is 0.00243 moles into the molecular mass of sodium bicarbonate will be 84.01 gram per mole. Therefore, mass of sodium bicarbonate reacted in this reaction will be 0.204 and the percentage mass of sodium bicarbonate in the antacid tablet will be equal to 0.204 divided by 0.30 into 100, which will be equal to 68%. So by this method, we can determine the strength of an unknown solution by means of a back titration once after the titration has been reached. And this method is called